Okay, we're going to take a look at slope. Slope is what we use to describe how steep a line is. Sometimes a line is not very steep at all, in the same way that a road or a mountain that you're going up may not be very steep, and then sometimes it's very steep. Well, we use slope to describe exactly how steep that line is. Now, the first thing that you're going to notice is the four types of slope. Uh, the first one, which I like to refer to as going uphill, is the positive slope. So you can see there that I have a car going uphill, and that's a positive slope. It increases from left to right. The second one is the negative slope, which is the downhill slope, going from left to right. So once again, you can see the car there going downhill. Then there are two special slopes. The first one is the one it's not positive, it's not negative. Well, if you think of the number that's not positive, not negative, but this is the one that you can still drive on, and that's 0. Okay, so it's not positive, not negative, but you can drive on it, and it's the 0 slope. It's a horizontal line, so it's flat. It's kind of like West Texas. It's real flat. And then the last one, and this is the one that I tell my students, I understand that some of them are probably going to try to drive on this one of these days, but this is the one that you can't drive on. And so there we've got a car trying to go uphill, but it's not going to work very well. So these are the four types of slope. You've got positive going uphill, negative going downhill. 0 is our flat horizontal one, and then undefined is the vertical one, and that's the one that we cannot drive on. Okay, now how do we actually find slope? Well, we find slope by using what's called rise over run. Now rise, think about rising up. It goes up and down. Run, think about running. You run left to right. You don't run straight up and down. So run goes left and right, and rise goes up and down. Now rise goes on the top of the fraction, and slope is always a fraction. Even when you have a whole number, it's always over 1. So slope is always a fraction. And the rise goes on top of that fraction, and the run goes on the bottom. So we're going to take a look over on the left. And you can see that we've got two sets of red lines and two sets of green lines. Well, we're going to start off taking a look at the red lines on the top point, so right here. Now, typically, whenever we do slope, I like to start with the left of the 2 points. So I would be starting with this point right here. However, you could do slope in any direction. This is just my preference to make it easier. Now, the rule is, on rise, if you go up, it's positive, and down, it's negative. So you can see here that we're going up. We're going up 1, 2. So I would take, if I went up 2, I would take that 2, and I would put it on top of my fraction. Then, and I'm going to switch over to green, you can see that from here, we're going to go over 1 to get to that second point. Now, slope, whenever we do slope, it starts at 1 point and it goes to another point. So here we started with that first point, and now we're ending up at this point, and we're going to have to go over 1 to get to that point. That's our run. Now, with the run, if you go right, it's positive, and if you go left, it's negative. Now, I said I like to always start on the left. Well, if we start on the left, then we should always be going to the right, and it means that the bottom number should always be positive. Now, like I said, you can actually do this in any direction as long as the run is on the bottom. So if you do go to the left, then it is negative. Now, what I want to show you is that this slope describes the entire line. And so if you take a look, we've got another set of red lines right here. I chose 2 different points on this line. And you're going to see that the slope still comes out to be the same thing because the slope describes the entire line. And so we're going to start with this point right here, and I'm going to go up. Now I'm going to go up 1, 2, 3, 4. So because I went up, it's positive, and it goes on top of my fraction. Then I'm going to switch over to green real quick. We go over to the second dot. And so now going over green, I'm going to go over 1 and go over 2. So that 2, we went to the right, so it's positive, goes on the bottom. Now if you take 4 over 2, 4 over 2 reduces to 2 over 1, which was the slope up here. So if you actually took any of those points on that line and you did rise over run in between any of those points, the numbers would always reduce to 2 over 1 because the slope of that line is 2, or in this case 2 over 1, because we always view it as a fraction. Now if you take a look over here, and actually let me go back to the left, one last thing I want to point out. Going from right to left, that blue line is a positive slope. So we should expect this to have been a positive slope. Now when you look over to the graph on the right, it's going downhill from left to right. So I would expect this one to be a negative. We're going to start off, once again, taking a look at the red lines. And I'm going to take a look at this one. We're going to start from this point. Like I said, I like to always start from the left of the 2 points I'm looking at. So we ended up going down 1. Now, if you go down, then that means it's negative. So the going down is the rise, and it's going to go on top of my fraction. So I'm going to put a negative 1 on top of my fraction. Then the run is how many we go to the right. And because we're going to the right, it should always be a positive number. So I go over 1, 2, 3. So that 3 is going to go on the bottom of my fraction. And my slope for this line is negative 1/3. And it describes, once again, the entire line. So if I take 2 other points, doesn't matter which 2, and I take, once again, I'll take a look at my red line. I'm going to start from this point. It goes down 1, 2. Going down 2 would give me a negative 2 over. And then if I counted my my run going to the right, it goes 1, 2, 3, 4, 5, 6. And I'll put 6 here. Now this, once again, reduces, and it reduces to a negative 1/3, which is the same thing that we got right here. So any part of that line, you could take any of those points, and it would always come out to be a negative 1/3 because it describes the slope of that line. Now, once again, we talked about at the beginning that the slope was negative, so we expected our final answer to be negative. Now, the reason why I point that out is because if you ever look at a line and you expect it to be negative and it comes out to be positive, it tells you that you did something wrong. Or if you expect it to be positive and it comes out negative, you know you did something wrong. Now what we're going to do is we're just going to take a look at these 2 lines right here. And like I said, slope always goes from point to point. So I've only got 2 points on here. And we will start off looking at the graph on the left. I'm going to start, I always like to start on the leftmost point. Once again, you can start on the right. And if you start on the right, then you'll end up going left. You just got to remember that going left is negative. But I always like to start on the right. So I'm going to go up from this point right here. I'm going to go up 1, 2, 3, 4, 5. So going up 5 means it's a positive 5 on top of my fraction. Then I'm going to go over to the right, and I'm going to go over 1. So if I go over 1, that's my run. And the slope that describes this line is 5 over 1. Now we're going to take a look over to the right, doing the same thing. And once again, let's go back over to the left. Well, were we expecting a positive slope? Well, if you take a look at this, it goes uphill from left to right. So yes, we were. Now, if we take a look over at the one on the right, we should be expecting a negative slope because it's going downhill. So we're going to go start from the leftmost point again, and we're going to go down 1, 2, 3, 4. So my slope is going to be negative 4 over, and then do my run would be 1, 2, 3, 4, 5, 6. So negative 4 over 6. Now this does reduce to negative 2 over 3. And so the slope that describes this line is a negative 2 over 3. And once again, if I was to find any other points on this, like right here, and I was to find the slope, you could see from that point right there that we would go down 2, and then you can see the green over 3, and we would still get a negative 2 over 3. Now we're going to take a look. This is, we used rise over run anytime that we're looking at a graph. And so we are going to take a look how you can also find the slope whenever you are looking at 2 points.